Okay, ABCalcs AB, Unit 5, Day 3, Office Hours. Spoke assignment. Here are the evens in case you haven't checked them yet. Pause the video and check them if you need to. Also remember, some of your answers might look a little different than mine. I mean, here's two different answers to the same problem. Very different looking, especially with trig and how you attack the problem. So, bunch of practice with trig derivatives for sure, also mixed in with some of the other rules that we've been learning. So number one, you're given a function. You should write the problem down. And then we're going to take the derivative. It's going to be negative 2 sine x minus 3 cosine x, and that's it. Let's see. Number 2, f of x equals sine x cosine x. So you got to do product rule. F prime of x equals sine times derivative of cosine, which is negative sine, plus cosine times derivative of sine is cosine. So this is going to be f prime of x equals negative sine squared x plus cosine squared x. And that's it. Number 3, f of x equals sine x over x. So you could do quotient rule, low d high minus high d low all over low squared. Final answer, x cosine x minus sine x over x squared. Okay. Let's see, number 4. F of x equals x squared cosine x. So this is kind of similar to the last one. I'm going to do a product rule. So f prime of x equals x squared times derivative of cosine is negative sine plus cosine times derivative of x squared is 2x. Final answer, negative x squared sine x plus 2x cosine x. So we want the stuff that's not inside the trig to be in front of the trig. It's less confusing that way. Number 5, f of x equals x cubed sine x plus or minus 5 cosine x. Derivative equals, we get a little product rule here, x cubed times derivative of sine is cosine plus sine x times derivative of x cubed is 3x squared plus 5 sine x, derivative of cosine is negative sine. Final answer, x cubed cosine x plus 3x squared sine x plus 5 sine x would be, I think, a nicer version of that answer. Okay, number 6. F of x equals cosine over x sine x. So there's some different ways. Now this is one where you could get creative. You could say cosine over sine is cotangent, and x in the bottom is the same as x negative 1, so you could do product rule with that. It's up to you. If you did quotient, you get low d high minus high d low. Got a little product rule in there. All over low squared. So then we're going to clean that up. So we're going to get negative x sine squared minus x cosine squared minus sine x cosine x all over x squared sine squared. We could factor a negative x out of both of these. Sine squared plus cosine squared, that's going to equal 1. So negative x minus sine x cosine x. So that looks like a good answer. Alternatively, you could have done it like this. And the derivative would have been a product rule instead. It'd be cotangent x times derivative of that would be negative x to negative 2 plus x to negative 1 times derivative of cotangent. Derivative of tangent is secant squared, so cotangent is cosecant squared with negative. Because remember, the derivative of any co has negative. So you're done with the derivative. You can rewrite it as negative cotangent x over x squared minus 1 over minus cosecant squared x over x. So, I mean, we could write that as the answer. We could try and get that to look like the other answer, which would involve changing this to sine over cosine, and this to 1 over sine squared. And then you're going to give these least common denominator. Actually, cotangent should be cosine over sine. So least common denominator, this would need an extra sine x. And this would need an extra x. So you would get negative sine x cosine x minus x over x squared sine squared. Same answer as I got the other way. Anyways, either way, kind of messy. Number 7, f of x equals secant x minus square root of 2 tangent x. Derivative this one. Derivative secant is secant tan minus root 2. Derivative tangent is secant squared. There you go. 8. So you could distribute this and do this like this, x squared secant x plus secant x. I don't know if that's going to make it any easier. Or we could just do it the way it is using the product rule, x squared plus 1 times derivative secant is secant tan plus secant times derivative x squared plus 1 is 2x. So we say f prime of x equals x squared secant x tangent x plus secant x tangent x plus 2x secant x. Looks good. If you do the other one, you should get the same answer. And you're still going to go do product rule. Number 9, f of x equals secant tangent. So f prime of x equals secant times derivative of tangent is secant squared plus tangent times derivative of secant is secant tan. So your answer would be secant cubed plus secant tangent squared. Something like that. 10. So we could just attack it straight on and do quotient rule. Or we consider that maybe things could be a little nicer. Change it to sine and cosine. So that's 1 over cosine. That's sine over cosine. So we multiply top and bottom by cosine x. You would get 1 over cosine x plus sine x. I mean, I don't know. Still got to do quotient rule. Maybe a little simpler. Now, if we just do it the regular way, the first way, quotient rule, low d high minus high d low all over low squared. Clean it up. Secant tan plus secant tangent squared minus secant cubed. So I don't know. That seems like an answer. Or if you did it the other way, you could do low d high minus high d low all over low squared. It drops out. Sine x minus cosine x over cosine x plus sine x squared. So that's another answer that should be equivalent to that other one. And so that's what I was saying. Just, just because it doesn't match back of the book doesn't mean it's wrong. It could be, though. So I'll just double check. Okay, number 11. So we could just do part rule the way it is, or we could say, well, maybe we could rewrite a little nicer. Cosecant over sine. Cotangent is cosine over sine. So I mean, I guess you could do cosine over sine squared, but now you're doing quotient rule. So I kind of think the first way is probably better. So cosecant x, I'm derivative cotangent, derivative tangent secant squared, so it's going to be cosecant squared with negative plus cotangent x times derivative cosecant, derivative secant, secant tan, cosecant is cosecant cotan with a negative. So negative cosecant cubed minus cosecant cotangent squared. So, I mean, that could be an answer. Otherwise, you could do it the other way. I'll just show it for fun. Low d high minus high d low. Now, this involves a derivative rule we haven't talked about. I mean, you could treat it like, like a product. Sine x times sine x. So it would be sine x times derivative sine is cosine plus sine times derivative. The other cosine is cosine. The other sine is cosine. All over low squared. So negative sine cubed minus 2 sine x cosine squared x over sine to the fourth. Definitely simplify. Divide a sine out of everything on the top. And the bottom. So, don't know if there's anything else we can do here. I mean, we could say this is negative sine squared x minus cosine squared x minus cosine squared x. And this is going to be negative 1. And so the answer would be negative 1 minus cosine squared x. But probably even, I don't know. So with this, if you were to distribute it, 1 over sine squared is negative cosecant cubed. And then cosine squared over sine squared is going to be cotangent. And there's another cosecant. Another 1 over sine is cosecant. And we can get it to match the other one. But whatever, lots of different answers. Okay, let's see. Got a couple tough ones on this next page. 13. So we could just try and tag it straight on like that. Or say cotangent is cosine over sine. Cosecant is 1 over sine. Multiply through by sine. Cosine over sine plus 1. So we're going to have to push one with that, but it looks like a little nicer. Sine, cosine, cotangent, cosecant, but work's probably going to be a similar amount of work. So if we do it the first way, low d high derivative tangent secant squared is going to be negative cosecant squared minus low d high minus high d low cosecant cotan all over low squared. Okay, so it's going to be negative cosecant squared minus cosecant cubed plus cosecant cotangent squared. We could say that that's the answer. And that's one possible answer. The back of the book doesn't have it like that because they went ahead and simplified it a little more. Because there's another trig identity. You could factor out a negative cosecant x out of everything on top, and then you have cosecant x minus plus cosecant squared x plus cotangent squared x. And so these trig identities, sine squared plus cosine squared equals 1. Divide everything with sine to get 1 plus cotangent squared equals cosecant squared. And so then that should be negative. So then cosecant squared minus cotangent squared would have to equal 1. So we say that's a 1. So that makes it a little cleaner. And that gives you a cosecant x plus 1, which cancels with one of the ones on the bottom. So we get negative cosecant x over 1 plus cosecant x. Or, in other words, another version of the answer would be negative 1 over sine x plus 1. How it works. lots of different, versions of the answers. Now, if you try to do it this way, then f prime of x would equal low d high minus high d low all over low squared. Right? Then we just try and clean it up. Negative sine squared plus 1 minus cosine squared. So we could take a negative out of the sine squared plus cosine squared. Should give you a 1. This should be a negative sine x. There should be a negative sine x. So be take negative of both of those, be 1 plus sine x. Get rid of one of those on the be negative 1 over sine x plus 1. And hey, what do you know? Same answer I got when I converted my other answer into sine and cosine. So that was 2 different ways to do the same problem, a couple different versions of answers. Okay. 15. Now, there's a really easy way to do this. You say this is 1, right? Otherwise, if you're going to try and do, and by the way, the derivative of 1 is 0. Done. Easy. Otherwise, if you can do this, there's a rule we haven't learned yet, so you would have to think of these as products and do f prime of x equals sine x times cosine x plus sine x times cosine x plus cosine x times negative sine x plus cosine x times negative sine x. And you would get sine x, cosine x, sine x, cosine x, negative sine x, cosine x, negative sine x, cosine x. It all cancel each other out. So, okay, 17. So, we could do it like it is. This one has kind of a nice way of simplifying a little bit. Secant is 1 over cosine, so we could rewrite it as tangent x over 1 plus x tangent x. So we do that. Or we do it the way it was originally written. So it's up to you. And if we did it the way it was originally written, let's see. Low d high. Now d high is going to be sine x times rho secant, which is secant tan, plus secant times rho of sine is cosine. So that's low d high minus high d low, which is going to involve product of x times rho of tangent is secant squared plus tangent x times rho of x is 1 all over low squared. Wow, that's nice. So then we would try and clean it up. Sine x secant x plus tangent x, sine x, secant x, tangent x plus secant x cosine x plus x sine x secant x tangent squared x plus x secant x cosine x tangent x. That's just the first ones. Minus x sine x secant cubed x minus sine x secant x tangent x. Oh my gosh. All over 1 plus x tangent x squared. That's a mess. Okay. Are there any like terms or whatever? I mean, I think what I want to do with some of this stuff is, let's see, sine secant tan, negative sine secant tan. All right, that works. See anything else? We could change some of these. Secant's 1 over cosine. So that's really just 1. And then, secant is 1 over cosine, so we could say that's x tangent cubed. And secant's 1 over cosine, so those cancel each other out. So that's x tangent x. And then and then this one, I don't know how we want to write that one. This is a mess. Okay. Secant is 1 over cosine, or no, we already did that one. Secant's 1 over cosine. I don't know. We could say x. 1 over cosine would be. We could do secant squared tangent x. So I don't know. I'm getting close to giving up on that one. I mean, that one's kind of gross, man. Is there anything we can do with that? I mean, factor an x tangent x out. I'm trying hard here. One of the Pythagorean triples up here, sine squared plus cosine squared equals 1. If you divide it by cosine, you'd get a tangent squared plus 1 equals 1 over secant squared. So then you could say, okay, well, 1 minus secant squared equals negative tangent squared. So we could replace this with negative tangent squared. And that gives you x tan times out is going to be minus x tangent cubed. So those guys cancel each other out. And we just get 1 over this. It's a lot of work. Clean these up. So, I mean, that's like the nicest answer I feel like we can get to. If you did it the other way, I mean, honestly, if you did it the other way, I would change this to sine over cosine. Multiply top bottom by cosine. I mean, I don't know. It seems a little better. I'll give you did that one. But if you did it that way, we do low d high minus high d low all over low squared. And you get cosine squared plus x sine x, x sine x cosine x plus sine squared minus x sine x cosine x minus sine squared. It's fun. Cosine squared and sine squared make a 1. X sine cosine x minus x sine cosine x cancel each other out. So you have 1 minus sine squared. Now, 1 minus sine squared would be cosine squared. Seems a little nicer. I don't know. Totally different answer. We could work on this one and make it look like that or vice versa, but let's not get too hung up on that. So, anyways, wow. Okay. Moving on. You need another piece of paper. Okay. 19. Oh, this one doesn't seem bad after all that craziness. So, we'll product rule x times derivative of cosine is negative sine plus cosine times derivative of x is 1. Final answer, negative x sine x plus cosine x. Easy. 21. Go product rule. Clean it up. Sine x 3, sine x is 4. Sine x. 25 has 3 parts to it. It says find the equation tangent line of the graph of tangent x at these following. Find the equation, and then so y prime would be secant squared, which is 1 over cosine squared. And so, I mean, that's how we're going to find our derivative. So for part A, it's x equals 0. So you got to find the coordinates. Tangent 0, sine of 0, cosine of 0, 0 over 1 is 0. So 0, 0. Slope is 1. So the equation of the tangent line is y minus 0 equals 1 times x minus 0. Which I'd be okay with that. You could also write that as y equals x. That's A. Part B, x equals pi over 4. So y pi over 4 equals sine of pi over 4 of cosine of pi over 4, which is bar root 2 over 2, root 2 over 2, gives you 1. So the point is that xy pair. Then we need the slope, y prime, pi over 4. It's going to be 1 over cosine of pi over 4 squared. 1 over root 2 over 2 squared. 1 over 2 over 4 gives you positive 2 for your slope. So it's going to be y minus 1 equals 2 times x minus pi over 4. And just leave it like that. If you really wanted to, slope in that form would be 2x minus pi over 2 plus 1. Sure, if you really want to. Okay, C, so x equals negative pi over 4. So y prime, or just y, and pi over 4, negative pi over 4 would be sine negative pi over 4 over cosine negative pi over 4, which will give you root 2 over 2 and root 2 over 2, but we're in the fourth quadrant, so cosine is positive, sine is negative. You get negative 1 for the y value. Then you need the derivative. And it's going to be 1 over root 2 over 2 squared equals 1 over 2 over 4 equals 2. Y minus negative 1 is plus 1. 2 times x minus plus pi over 4. Or, if you insist, y equals 2x plus pi over 2 minus 1. Okay, equations of tangent lines. All right. What's the problem? 35 says, make a conjecture about the derivative by calculating the first few derivatives and observing the resulting pattern. So they want the 87th derivative sine x. Okay, well, y 0th derivative is sine x, y prime is cosine x, y double prime is negative sine x, y triple prime is negative cosine x, y to the 4th is positive sine x, and we're back to the beginning. So what we need to do is take 87 and divide by 4 all the full cycles out. Now it's like 21. And the remainder is the key, because this says that the 87th derivative is going to equal the third derivative, which equals negative cosine x. Part A. Part B says we're going to find the 100th derivative of cosine x. Okay, well, the 0th derivative is cosine. The first derivative is negative sine. The second derivative is negative cosine. The third derivative is positive sine. The fourth derivative is cosine. And we're back to where we started. Repeating groups of 4. 100 divided by 4 is 25. Remainder is 0, which means it's the same as the 0th derivative. So the 100th derivative is the same as the 0th derivative. It's the same as the original function. That's it. Man, bit of work. Good practice.